Scientists, today we're going to look at the last section of how to write a science lab report, which is evaluating the validity of the hypothesis and method. If you haven't watched the previous videos in this series, I suggest that you watch those first so that this one makes more sense. The first one is on the background information, hypothesis, and variables. The second on method, the third on the results, and the fourth on the conclusion. And just use those QR codes to access the videos. So today's video, again, we're going to learn how to evaluate the validity of your lab report, and we're going to look at your hypothesis and your method. So we will ask, did the results match the hypothesis? Why or why not? And then we're going to reflect on how well the experiment was planned and carried out. We will identify the strengths and weaknesses in the method, and we'll suggest realistic changes to improve accuracy and reliability. So we're going to be thinking like a scientist. Your job is to improve the investigation, not just report on it. So let's look at evaluating the validity of the hypothesis and method. First, you have to answer, do your results agree with your hypothesis? And if no, why? Then you'll need to evaluate how well your method and experiment worked. You'll list all the strengths, and you'll identify all weaknesses and suggest changes to improve reliability and accuracy if appropriate. I like to make a table for this, so I have 3 columns, and I organize it this way. In the first column, I describe the area, and then I indicate whether this was a strength or weakness. Then secondly, I talk about how this positively or negatively impacted my experiment's reliability and or validity. And then the last column, I suggest any relevant changes or improvements. So here's an example of a question that you could answer. An error can be something from the written method that didn't work well or wasn't clear enough, or it can be something that went wrong when you were doing the lab. So if that happens, you can explain how your measurements or results might be wrong due to this problem. And then lastly, you can give a specific step that could be done to correct the problem. Now, it has to be something that you could add to the method or make clear so that the problem would be avoided next time. Another area you could look at is, how does your method give instructions to measure each variable? And is that a strength or a weakness? How could this instruction have caused errors that may have impacted your results? And then how could this be improved? Again, are there any extra steps or details that should be added? The third area, you could look at your method and see if it gives you a big enough range of data or sufficient data to see a valid relationship and why it would or would not. And again, how could this have caused errors that may have impacted the results? If that's a negative impact, how could this be improved? Are there any extra steps or details that should be added? And lastly, which other parts of your method could have caused error? And again, how could this have impacted the results? And how could you improve this? Are there any extra steps or details that should be added? Here are some more questions that you could use to extend your evaluation, because remember, details lend clarity to your writing. So you could ask, how does your method give instructions to measure the dependent variable? How does your method give instructions to change the independent variables? Are there any controlled variables that you would like to add, alter, or remove, and why? How does your method give you a big enough range of data or sufficient data to see a valid relationship? List all the pieces of relevant equipment not included. How does your method give instructions to conduct enough trials? And did you make any errors while carrying out the experiment? And if so, explain. So let's do an example. And again, I'm going to use the same example that I used in my previous videos on the helicopter experiment. So first, do my results agree with my hypothesis? And yes, they do. Now I'm going to make my table. Again, the table just makes it look a lot clearer and organized. So I have my 3 columns. And again, the first column is the area that's either going to be a strength or a weakness. And I started out with a weakness. And the weakness was that the tape measure was not always at a height of 453 centimeters. So the impact it had was negative because it meant that the helicopter would have fallen different distances, which may have affected the time. So how can I improve this? Well, I could measure the height the helicopter should be dropped from and then mark this on the wall, and then drop the helicopters from the mark to ensure consistency. My second one was another weakness, and this was with the timer, because the timer was not always started and stopped at the exact moment that the helicopter was released and or hit the floor. This had a negative impact because the time recorded was not accurate. So an improvement? When beginning the timer, use a countdown to know when to start the timer. The same person should press the button to ensure a consistent reaction. Then I found a strength, and the strength was in the method, and this was my independent variable. And it was positive because I included in my procedure how to change the independent variable with enough data increments to collect consistent data. I used 5 centimeters, 4 centimeters, and 3 centimeters, and this can be found in steps 2, 7, and 10. There's no improvement because it was a positive impact. Another strength was the dependent variable. It had a positive impact because my procedure had steps to tell how to measure the dependent variable. It says, start the timer as soon as you let go of the helicopter and stop the timer when the helicopter reaches the ground. And that can be found in steps 4 and 5. Again, no improvements needed since it was a positive impact. And another strength was my control variables in my method. It was positive because my procedure included all 4 of my control variables. The constant mass was located in steps 8 and 11. The height released was in step 3. The method of releasing was also in step 3, and the environment was step 3. Again, no need to improve upon this since it was a positive impact. Lastly is my bibliography, and make sure that you cite all of the resources that you use. And again, notice that the way that it's written is in alphabetical order. That means that we go from A to Z, in this case from C to U. And you can use Noodle tools to help you with this because it's a great resource to help you document your sources. And just a reminder that in science, we always use APA citation. So what makes a strong evaluation? Well, it states clearly whether the results support the hypothesis. It reflects on how well the method worked and why. It identifies our strengths and our weaknesses, and it suggests logical changes to improve the experiment. Answers questions like, were variables well controlled? Was enough data collected? Were instructions clear for measuring and changing variables? A strong evaluation shows you understand both the results and how to improve the science behind them. If you liked this video, please click the like button. Feel free to leave a comment, and if you haven't subscribed yet, please do so you have access to all of the videos on how to write a lab report and also on mathematics. As always, thank you for watching.